Okay, yesterday we stopped at this tutorial question. Okay, we learned the last part of chapter 1. Maybe just 5 minutes, then we moved on to chapter 2. Okay, so today we're going to learn relative motion. Means comparing another object with another two object, right? So on the screen here, you have 3 objects. 2 is moving, 1 is stationary. So we always start our question with fixed observer, which is something that do not move. We have a fixed observer, so when every time the item or the object is fixed, then we will establish the XYZ coordinate, which is the reference axis, and we label as O. So the first object is fixed, because when the question asks you relative of something, you need to have a fixed reference point. So we start with the fixed reference point with one person or one object, and we label as O and establish the XYZ. Then the second observer, which is moving, because we are studying dynamics, so we have a moving object. On the screen here will be the object A, and the motion can be rectilinear, can be curvilinear, but this A is also moving. So when the object is moving, we establish second global position, which is labeled as XYZ also, but with the prime. Okay, with the prime. Prime means the second moving object. And then the third object is also moving, which is on the screen here is B. B also moving. So we establish the displacement towards that moving object. Okay, so relative motion, we are referring to 3 objects or 3 points. 2 is moving, 1 is fixed. So to solve this relative, once you see the question, calculate relative motion of something, then is fall under this one. So the first step is to establish reference point or reference axis. You need to identify which one is not moving, or which one do you refer to. So the first one, you find the fixed object. Then you draw X, Y, Z. If it's 2D, then more easier. You don't have Z, just X and Y. And then the second object, it is moving. You choose rather which one and which one. So these two are moving. You need to read the question carefully. All right. So how you know it's A or B? Usually you need to read the question, what relative to what. So if the question asks you B relative to A, B relative to A, then B will be the observing object. Okay. So then once you have the axis, then we establish the vector, the distance vector, or in this case we use R, distance vector or relative distance. So first vector is A looking at O looking at A, the fixed position towards the first object. Means you label as, you draw the arrow O to the first object which is moving. All right. So you write the arrow from O pointing to A, and then you write RA. R sub A means from the fixed position looking to A. Then you from the fixed position also to the another object. You fix arrow, drawing arrow O to object B with the arrow pointing to B, and you label as RB. Then from the object A looking to B, all right, looking to B. So this one is, if you put A pointing to B, then the R should be careful. the R, you should not flip the sequence. If A looking to B, then you write R, B, stroke A. Don't write A, B, stroke A. Yeah? So if A pointing to B, then it's R, B, stroke A. If B looking to A, then you cannot solve the vector problem. Yeah. So always have one relative to another one. So once you build this one, the difficult part is this R stroke B, R B stroke A. This is a difficult part. Okay. Usually is object A to B. So this one you need to refer to the question. The question asks you relative motion of B to A. Then the arrow will be B from A. B from A means the arrow will be pointing from A to B. You need to read the question, what refer to what. Okay, again. So in the question, you need to read carefully what question you need to solve. What parameter you need to solve. If the question asks you to solve B relative to A. B relative to A means you're looking from A to B. If the question asks you B relative to A, B relative to A means the focus is, the eyes is from A to B. Yeah. So this is a bit critical part. So if the question asks you solve relative motion of B relative to A, the vector should be pointing from A to B and not B to A. Relative to something means that is from the source of, from the arrow. And you write this one, B slash A means B relative to A. And then there's a cheat code for that. RB stroke A equal, you transform the slash become minus. BR stroke A, B sub B stroke A equal RB minus RA. You just need to remember that lah. That is a cheat code for that one. All right. So yeah. So if you really don't know, then you look at the triangular, then you know already lah. So from the triangular, if two arrow continuous following, then it's the process. If you see the two arrow continue, RA continue to RB stroke A, this is a process. Process will equal to the result. The result is RB equal to RA plus RB stroke A. Then you rearrange the equation also, you get RB stroke A equal RB minus RA. You get the same equation. Yeah? All right. So the rest you read. I already explained just now. The rest you read. Okay? The rest you read. So you are free to write whatever you want. But I already give you the cheat code. If you see RB stroke A, convert the slope become negative. You take RB minus RA. That is the equation that you're going to use. Okay. So you, from the question you read object B relative to A, you straight away you write RB stroke A equal RB minus RA. And that is the first equation you read, you can extract from the question. Okay. Then what is RB stroke A? Is a relative position. Then you know that from this equation, when you differentiate with time, distance differentiate with time, you get velocity. R become V. So first equation you establish either the first equation or you write RB stroke A equal to RB minus RA. Then you differentiate the R equation, you get velocity. And you differentiate one more time, velocity, you get acceleration. Okay. These three are the main equation. How you arrange it is up to you, as long as it's in the correct operation. Either you want to write VB stroke A in the front or at the back, is up to you. Okay, make sense? Yeah. Okay. Let's apply what you learn. So again, first you read the question and then find what actually question asks you to find. What relative to what? You need to find 3 points. One is fixed, two is moving. From the question, you identified 3 points. One is fixed, two is moving. Okay, so from the question, a train travel at a constant speed so and so in kilometer per hour. Be careful. In this module, you need to use units SI. Convert all the kilometer per hour into meter per second. Okay. If the automobile or the train A is traveling at a certain speed along the road, determine the magnitude and direction of the velocity of train relative to automobile. So it depends. So this is a bit general question. In this case, it just straight away go and solve in kilometer per hour. So, but in the test, you need to convert into meter per second, right? So, okay, just observe. You are given a diagram with this T move in the straight line, and then there is a car moving at another position. So it asks you, determine the magnitude and direction. Magnitude direction means you have the direction, and then the magnitude, if you have x and y, then you have vx, vy. Then you square the vx square plus vy square, square root, you get the magnitude. And then you take the tangent theta, inverse tangent, you get angle. Okay. Now observe there are two solutions. There are two solutions. I use vector analysis first. So it asks you, velocity of the train relative to automotive. So is train relative to automotive. So the arrow is pointing like this. Train relative to A. So it's from A, you look to the train. Okay, so you write the first equation. Train relative to automotive. Vt stroke A equal to Vt minus Va. You read the question and then you convert into equation. Yeah. So here from the question, train relative to automobile. So in the diagram, you're given the train is T, car is A. So V, train relative to automobile, train relative to automobile. Convert the slash into negative, Vt minus Va. Or you can rearrange like what you see on the screen here. It's the same equation actually. Okay. Then you solve in y and x axis. You see the question as x problem and y problem. So Vt, you write you convert everything into x, y, I, j, k. So Vt is towards x-axis because it was given the x and y. So x-axis 60i Vt train. Va is what? You know the angle, right? So how to get in Vax? What is Vax? Yeah. So Va, this one, got Vaxi plus Vayj. Right? Because this is in this direction. Va. And the angle is 45. Because 45 is given here. Right? So you split into x and y axis. So go to Vx equal and go up is Vax and Vay. So Vax equal to cos or sine? It's a side. If it's a side, then it's cos. So VA cos 45. Or if you're familiar with 1 over square root 2 or 3, that one also can use. But if not, then you just write cos 45 and then press calculator. This one, VAY equal to VA sine 45. So input this one into here. VT stroke A is what you want to find. So there's only, once you have this one, then you know how to, if the I, you group all the I together, then do the normal mathematic. Then you group all the J together, do the mathematic. If got K, then you group all the K together, do the mathematics. Okay, so on the screen here, I give you some working here. All right, so who don't understand how you get this one? How to get the second line here? Who don't understand? Okay, now? All right. So then you rearrange the equation. VT stroke A is the question want you to solve. So you write VT stroke A equal, then you simplify the equation. I you put together 45 cos 45 cos 45, you press calculator. Then you move from the left, right to left is minus. Then you get the I. Cos 45 sine 45, 31.8. So just some of you might have careless mistakes where you move things around. This one positive when you move from the right to left is minus. Some of you have this issue when you move, you carry together. But remember to change the sign if you change from left to right or right to left. Okay, and put in kilometer per hour. So this is a tutorial question. So it will be very, very general. But when it comes to test or final exam, the question will specific mention, put your answer in meter per second. Yeah. All right. So the step will go along this one. So magnitude is to square the x, square the y, square root, you get the magnitude, and then you should able to draw this vector. So how to draw vector? So you have your y and x. So 28.2i is going this way. Is I. Then minus 31.8, go down. 31.8 j minus. So going down. So you know that the angle is here. Angle is here. This is your theta. So you build your trigonometry. It's a triangular. Right? So you get the tangent of y and x. Yeah. Oh, this is your r. So you can use, this is opposite and hypotenuse. So it's sine, inverse sine. Sorry. It's side and opposite tangent. Sorry. Yeah. Okay. Okay. So we continue. The rest you already know already lah. So important, you need to draw the vector diagram. Okay. So convert this one into vector diagram and then show me where is your angle, where is your resultant. So you label this one is the resultant of V T stroke A. Magnitude square plus square again. This is also careless mistakes. When you square negative, it become positive. Then the answer is 42 point something. But the value is not important. Important you understand the steps. Okay, then direction is inverse tangent 48.5, and important is once you have the diagram, I know where is the direction already. Okay, this is the first part where if the question forces you to use vector analysis, then you need to show me I, J, K terms in your answer. Okay. Right, try to understand the logic of solving. Okay, I repeat. First, the first step is to read the question, understand the question. What actually question asks you to solve? So here is train relative to automobile or train relative to car. So VT slash A or VT slash car. Once from there equal, convert the slash into negative. Then from the question, you convert everything into IJK. Then you solve vector problem. Okay, I show you. This is solution 1. Solution 2, I don't do, but I just show you the analysis. Okay. Number 2, since you are in the aerospace degree program, so you cannot run away from the aircraft. So you are given 2 aircraft. One is A, one is B. A is a rectilinear motion in the straight line. B is in the curvilinear motion. And you're given the R. So flying straight, plane A flying straight line, plane B curvilinear motion, radius is given. Determine the velocity and acceleration of B as measured by pilot A. So the first equation, are you able to write or not? V what? V A stroke B or V B stroke A? Measured by A, so V B stroke A. So once you have that, VB stroke A equal, then convert the slash into negative. VB minus VA. Then you extract information from the diagram. What is VA? What is VB? So, and you look at the diagram, it gives you the XY, it gives you the X prime, Y prime, and you know that curvilinear motion, you need to refresh back. Once you see curvilinear motion, what you need to do? Establish tangent and normal axis. Once you see curvilinear already, straight away establish tangent and normal. Okay, the rest you read. So this is the vector diagram that you can draw. Okay, because the 2 aircraft is going, the 2 aircraft is going opposite direction. It's going opposite direction. A is moving up, B is moving down. So VA move up, VB, VB in this case, I point up. No. Both aircraft is moving same direction. Sorry, the one that pointing down is acceleration. Okay, move is pointing up. 700 kilometer per hour go up. B is 600 kilometer go up. So you want to find the difference, right? So vector VA is longer than vector VB because both aircraft is moving in a straight line. So VA is longer than VB, and you want to find the difference. VA stroke A means is the difference between the 2 vector. So this is the distance you want, right? Okay. So you write the equation. Even though you don't know how to draw this vector, it's okay. But what is important, you able to write this equation, VB stroke A equal to VA minus VA. And then you can rearrange what you see on the screen here, or you can maintain as VB stroke A on the left-hand side of the equation. Okay. The one you see here is textbook answer, but you are free to write the way that you want, as long as the operation is correct. Okay, VB, because all the direction is in Y direction, Okay, all the direction is in y direction, so you can see it as all the y direction. So VB equal to 600, VA is 700 equal to VB minus VA. So from here you know that VB stroke A equal to what? Negative 100. So from this answer, that's why you can draw this vector diagram. From your calculation, you can convert the VAVB is pointing up, but the final answer you get negative means the arrow pointing opposite direction. Okay. So this is how you solve for that. Okay. So once you have the relative velocity, you need to find acceleration. So same. Okay. So acceleration, you know that B is in the collinear motion. So you need to establish your AN and AT. So you know that call back in the collinear motion. What is your AT? AT is the time differential. You take your velocity differentiate by time. VT differentiate by time. Okay. So Vn, you know that is this equation. Vt square divided by rho, or V square over rho. You take the tangent velocity square and divide by rho, right? And if the rho is not given, you can calculate from the equation, the y equation, right? So you substitute the value, you get 900 kilometer per hour square. All right. Now again, when you see collinear motion, you need to recall the slide that I showed you. One of it is AN equal to V square over rho. So you know that from the VB stroke A equation, you can differentiate with time. You get AB stroke A equal to AB minus AA. Or you can write in VAB equal to AA plus AB stroke A. So you can also convert AB equal to 900 minus 100J. Do you know why I can write 900I minus 100J? We are converting the n into x and y axis. The AN is pointing inside. AN is your AX. AN pointing x direction. Pointing x direction. And your AY is given in the diagram. AY is going down. That's why negative 100J. Okay. So you need to smart enough to convert between normal and tangent into x and y. AA is going up, so 50J is given, acceleration is given in the diagram. And there's only one missing parameter, which is acceleration of B from A. Okay, you can read the slash as from, the word from. B stroke A or B from A. Then you solve the equation, you group I together, J together, K together, you solve, you become one vector equation. Once you have vector equation, you can find magnitude and direction. Direction means angle. Okay, so don't stop here. Once you have the vector answer, don't stop here. You need to continue by telling me what is the magnitude and direction. Don't stop here. So square 900 plus square minus 150 square root. And then you need to draw the vector diagram. 900 is positive value going up. sorry, going to the right, minus 150 going down. So the angle is okay, going down on the right hand side. Okay, so I just straight away give you the answer lah. But the step you should already know how to get 912 and 9.46 by from the vector diagram. Okay. Okay. All right. So you need to show me a direction from the vector diagram. It should be in this direction. Okay. With this, we conclude chapter 1. We have maybe 10 minutes break. Okay. Now it's 11:40. We continue 11:50.